So in the fall, we talked about how to shift functions, left, right, up, down, stretch them, reflect over the x-axis or reflect over the y-axis. We're now going to be doing that with trig functions. So I'm going to get everything set up in my calculator so I can view everything good and pretty. First off, I'm going to make sure I am in radians. I am. I'm also going to go to the table setup, and I'm going to change a few things. I'm going to start at 0, and I'm going to have my table count by pi over 4s. In something else I had done, I had this on ask, but now it's just going to set up my table by pi over 4s. Now, of course, that doesn't look like pi over 4, but it is. And then I'm going to hit the window key, and I'm going to make my window match the window that's on the assignment. So I'm going to go from 0 to 4 pi, and I'm actually going to have it count by pi over 4s. And then I'm going to go from -4 to 4 and let it count by 1. So I think that's going to be fine. So now I'm going to put in this function. So I'm going to have 3 sine up to, well, I have to put 2x in here. And let's look at the graph. All right, so it's a sine wave. Looks a little taller than the basic one that only went up to 1. So now I can look at my table, and now it is counting by pi over 4s. So what this one does is it starts at 0, and then it goes to 3, and then 0, whoops, goes to 3, I don't know what I was counting, and then it goes to -3, and then it goes back to 0 at pi, which is 3.14. Then it goes up to 3, 0, -3, 0, and it's going to repeat itself. So I kind of got the idea of the pattern. Down, middle, up, down, down, back. And it is a wave. I saw that when I looked at the graph. Here. Sorry for the sound effects. For some reason I have to sing when I graph. Okay, so let's think about everything. First off, let's talk about the range. We know the domain, it's infinity to infinity. That's okay. The range is going from -3 to 3. So that means my amplitude is 3. The next thing I want to note is my period. The period, how long it takes to repeat itself. Instead of being 2 pi, like the original, it's repeating itself every pi, so it's squished. Now, looking at the equation, there's some things that the equation told me, so we'll talk about that. When we have a number, and technically that should be in parentheses, in front of our graph, what that did was it vertically stretched by 3. Now, when I have a number inside with the variable, with the input variable, it does the opposite. So when we added, it actually moved it left. When we subtract, it moved it right. I'm not having any adding or subtracting here. There's multiplication. But instead of horizontally stretching that sine wave, it squished it. Instead of being a period of 2 pi, it cut that period in half. So this is a horizontal shrink by 1/2. half. So it took my normal period of 2 pi and cut it in half. So that's interesting. Now, did we have any shifting left and right? No left, shifting. No shifting at all. No shifting. Oh, that does not look right. No shifting. So it didn't move left or right. It just kind of got stretched up and it got squished horizontally. Let's go to the next one. Okay, so this one has 2 and by desmos as well, if you don't have a graphing calculator at home. 1/2 plus pi. Ooh, I see that plus in there, so I think there's going to be some shifting, but we'll figure it out. So I'm going to look at the graph first. Whoa! Those are some big waves this time. And I'm going to go to the table. And remember, I'm counting by pi over 4s because we set the table to do that. And it is going 0. Wait, hold on. It usually went up, but it's not. That's kind of interesting. It's going down instead. And then it goes, oh, it's by pi, it's down to -2. I'm going to kind of stretch that out. And then at 2 pi, it's back to 0. And then it would go, I bet, by 3 pi, it's going to be here. And I bet it's going to come back here. So this one's different. Really, really different. It's really, really wide. There's a couple of things I want to make note of. Let's start with the range. The range is going from -2 to 2. And that means my amplitude is 2. The period is 4 pi. That's crazy. 4 pi instead of 2 pi. So it's doubled. And there also seems to be some shifting. Like normally it went up first. So it's sort of like the graph got shifted left somehow. So let's talk through that. This 2 at the front, that's a vertical stretch by 2. Okay. The 1/2 in front does the opposite. This is a horizontal stretch by 2. So the period went from 2 pi to 4 pi. But this shift that I see going on, it's sort of like that the whole graph is shifted by 2 pi. So I'm wondering how that works. So what I'm going to do is I'm going to take what's in the parentheses here, and let's set that equal to 0. So I'm going to take what's inside the parentheses and set it equal to 0 and solve that equation. So I get 1/2 pi equals -pi, and then I'd multiply by 2. So when I do that, I get that I have my first 0 at -2 pi. So that means way over here at -2 pi is where the first 0 starts. And then it would have gone up and then down. So technically what has happened here is this is a shift left 2 pi. So that's the neat way to be able to figure out if I have this shifting, phase shifting, if you will. The graph was shifted a little bit. Let's try the next one. Okay, now on this one, be careful. When I typed it up, I didn't make sure it was separated very well. So that +1, that's not plus ion. That's a +1. Okay, so I wonder what that negative is going to do. And I wonder what the +1 does. Ooh, the midline is no longer the x-axis. I see that. Oh, it shifted up a little bit, didn't it? Also, I'm starting at the top of a hill instead of where I think I should start, which is at 0, 0, which is where sine usually starts. So there's a little bit of a left or right shifting too. Let's go ahead and go to the table and use that to plot our points. So 3, 2.4, and the next one is a 1, then negative 0.4, then back to 1, 2.4, 3, 2.4, 1, getting the pattern, negative, there, up, there, up, there, and there. Okay. And we saw that it was our lovely sine wave, and it is called a sine wave, by the way. So this one's a little odd as far as telling where the midline is. I missed something. Oh my goodness. I missed a point on this instructions and it ruined my whole graph. Oh goodness. I normally would just re-record this, but I don't really want to, so let's fix it. If any of y'all caught my mistake, good for you. 3, 2.4, 1, negative 0.4, and then it was another negative 1. See, I knew something was weird. There, then it goes back up to 1, and then it goes to 2.4, and then 3, then 2.4, 1. I cannot believe I messed up that badly. How did y'all let me do that? I know, you didn't have a choice. You weren't here to help me. It goes negative. And there we go. I'm recording this, so you will hear bells occasionally, even though none of y'all are here. So ignore the green line. Let's only look at this pink line. If you have trouble ignoring it, I will make it go away. Like it was never happened. Okay. Golly. So we have a middle line kind of right here, which is nice to see. Okay, so my range is from -1 to and that makes my amplitude 2. my period, see how long it takes to repeat itself, is 2 pi. And there's a couple of weird things going on. First off, let's talk about the equation. So this negative in front, that usually reflected over x-axis. Okay, so we've got some interesting things going on. The 2 is a vertical stretch by 2. Now on this one, I did not have that number in front of the theta that gave me that shift, period change, the normal period. Now to talk about left or right shift, I'm going to take what's in the parentheses and set it equal to 0, and I get a pi over 2. So we have a shift right pi over 2, which makes sense because I'm subtracting pi over 2. The plus 1 at the end makes the whole graph go up 1. That's why my midline is now at 1. Based on your observations, what do to the graph? What does the B, if you have something times theta, do to the graph? Well, A is my amplitude. When there's no number there, it's a 1, so my amplitude is 1. The B actually affects the period. It's going to be the normal period of 2 pi divided by B. So let's see if that works. The B here was a 2. 2 pi divided by 2 is pi. This one had a 1/2. If I take 2 pi and divide by 1/2, that's the same as multiplying by 2, I get 4 pi. See if we can do this without having to do any work. What would be the period? So feel free to pause, try these, and then come back and see if you got them right. Easy one, huh? Now, there's one thing I'm going to add on to this one, the phase shift. So, if I took what's in the parentheses and set it equal to 0, that's going to give me my phase shift. In other words, which way I'm shifting left and right. So that's left 8. Next one. Let's see if you get the range on this one right. Why is my range 1 to 5. This plus 3 moved the whole graph up 3. That's the new midline. So I'm going down 2 from there and up 2 from there. Let's try this one. Did you get that one right? If we went, oh no, that was secant. Okay, so there isn't really an amplitude for secant. And what's going to end up happening is the hills are going in the opposite direction. So instead of being between -7 and -1, it's really going to be -infinity to -7 and then -1 to infinity. I'm remembering what secant looked like. Now tangent. Okay, so I've got to remember tangent, and so I'm going to use my handy dandy chart. Tangent had a period of pi. So if I do a 1/3 here, my new period would be pi divided by 3. And for tangent, my range was -infinity to infinity, so that's not going to change. Cosecant. Oh, this is a hard one. Oh my goodness. Okay, so cosecant had a period of 2 pi, so my new period would be 2 pi divided by 2, which is pi. Now, it's not really an amplitude, but I'm just going to write it down just for... And normally that would mean I was going... Okay, so we're midlined at -1. We go down 3, and then up 3 from -1 would be a 2. But I'm not going to be between those. I'm going to be on the outside of those. Let's look at this graph. Which one does it look like? That sure looks like sine. Because it starts at 0 and then goes up. Now, what would be the period if I did 2 plus, it says f, so we're talking about sine. So 2 plus sine of 1/2 theta. Well, okay, so the period would be 2 pi divided by 1/2, which is 4 pi. What would be the domain and range of that graph? Well, the domain would be -infinity to infinity. If the whole graph is shifted up 2, and my amplitude hasn't changed, then from 2 I'm going down 1, up 1. So down 1, whoops, oh my goodness, from 2 down 1, up 1. Woo, that was hard. Whoops, I forgot the S on sine. So this is -3, so the whole graph has moved down 3. And this changes my amplitude. So I'm going down 3, up 3. So -3, down 3 from that would be -6, and up 3 would be 0. Suppose we had, so that's still f, sine of theta minus pi over 2. What? Okay, so which trig function would result? So what happens then? So that's a shift right pi over 2. What would that give me? So here, I'm going to borrow my notes from last time. If I took this whole graph and moved it right pi over 2, or I can look at it in the calculator. Let's look at it in here. Sine of theta minus pi over 2. That kind of looks like cosine, but flipped. So it's kind of like negative cosine. Interesting. Ooh, which one does this look like? So I invite you to go ahead and try these. Pause this, try them, and then when you come back, you can check your answers.